things in this topic. One of them was the area of parallelograms. So before you can finish this problem or start this problem, what is the formula to find the area of a parallelogram? Base times height. So the area of this parallelogram is equal to the base times the height. And you have to choose the correct base, and that's the one that's between the corresponding base for the altitude. 36. So it's 36 times the height, 33. That'll give you the area of your shape. Inches squared. That'll be a multiple choice question. It'll say 1,188 inches squared is A, B, C, or D. Not a very tough question. Anybody scared of that one? All right, number 2, finding the area of a triangle. What's the formula for area of a triangle? Whichever one you like. So, how long is the base? Now, don't fall. This is not part of the triangle. This is just telling you what the height is. So, area is equal to, are I using, which formula are you using? Top or bottom? The bottom one? 4.4. My computer's slow today. Base times height divided by 2. So 4.4 times 2 divided by 2 is 4.4 centimeters squared. That's the area of that triangle. Scared of that one? Not really. Just make sure that we're using the correct height. We don't want to include this little piece right here as the base because it's not there. Alright, so this one is a composite figure. It's got a parallelogram and a triangle. So for this shape, we're going to have to do area equals base times height. And for this shape, it's area equals base times height divided by 2. So we need to add 2 areas and then add them together. So you want to do the parallelogram first or the triangle first? Which one? The parallelogram. So we're going to find the area of this parallelogram, base times height. What's that? 117 centimeters squared. Okay, now we need to find the area of the triangle, so you have to do a little bit of math here to figure out the height of this triangle. You already have a base. It is 5 because this whole piece is 13, and you take 8 away, that height is 5. So now 5 and 8 make 13 on the right side. So it's base times height divided by 2. Or 27.5. So the final answer is to add those 2 areas together. $139.5. sorry, it should be a 7. $144.5. Centimeters squared, sorry. Not terrible. Finding this number could be a little bit confusing. Number 4. So this whole length is 10. The height is 3. Find the area of the triangle. Base times height divided by 2. 15 yards squared. So that kind of ends 13.1. That's all your parallelograms and triangles. That was last Wednesday. Any issues or questions on that particular topic? So now we get into Thursday, which is trapezoids and kites and rhombuses. So I put a little orange background on this one because I think it's one of the more difficult questions on the review. So we have to know the formula for the area of a trapezoid. That is 1/2 base 1 plus base 2 times the height. So we have to know both bases. Huh? So if this is 2, how long is this one? If this is 5, so the whole bottom is 9. Base 1 plus base 2 times the height. I can't really do that in my head. No? I was lied to. 63.5? 63? Right. I got 58. Alright. 0.5 times 13 times 9, 58.5. Yes, ma'am.
9 plus 5 equals 14. Yeah,
Oh, man. Alright. Is today Monday or what? So it is a hard question. 63. Huh? No, it's not. It's 63. Because it's 1/2 14 times 9, or 7 times 9 is 63. Man, that's embarrassing. Like I said, it's a hard question. Is it though? Is it that bad? No? Let's try. I'll do my best not to screw this one up. Same thing here. It gives you all the information. You have base 1, you have base 2, you have a height, 1/2 the sum of the bases times the height. Huh? I did that in my calculator, in my brain. You wanna check me? It's half of 20, which is 10, and 10 times 7 is 70. Right? Did I do it? Redemption. Alright, so now we get to the kites. So you look on your formula chart and it says rhombuses, but rhombuses and kites have the same formula. The area of a kite is 1/2 diagonal 1 times diagonal 2 is the length of the whole diagonal. So the area of this kite is 1/2 times 18 times 4. And 1/2 times 18 times 4 is 36 feet squared. So you have to use the length of the whole diagonal. 2 plus 2 is 4. And 6 plus 12 is 18. So it's the length of the entire diagonal. Alright, it's got some color to it, so it means it's supposed to be a little more difficult. This one is a little bit more tricky because I'm adding more geometry to do just a little bit of geometry. So for this question, you have to know that all those shapes intersect at a right angle, which creates a 30, 60, 90 right triangle. So if this piece is 9 units long, this piece has to be 9 units long. That creates a special right triangle, a 30, 60, 90 right triangle. This is our 1 side, this is our 2 side, and this is our square root of 3 side. So to get from 1 to the square root of 3, you multiply by the square root of 3. That means that the length of the other half of the diagonal is 9 square roots of 3. If this length is 9 square roots of 3, this length is 9 square roots of 3. So using special right triangle tricks to find the length of the missing diagonal, then we use our same formula, 1/2 of diagonal 1 times diagonal 2. So I'll have 9 square roots of 3 and 9 square roots of 3. It's 18 square roots of 3 total. So we multiply all that together. You get a decimal answer of, can't do that.
Bless you.
Or you get a radical answer of so finding that radical answer, if you do 0.5 times 18 times 18, you get 162 with the square root of 3. And you can, if you do 162 square roots of 3, you get the exact same answer if you type it in. So I would encourage you, if you're not confident in working with radicals, to take all of your answers, A, B, C, and D, convert them to decimals, and then solve for the answer as a decimal and see which ones match. Does that make sense? So type that in and see what you get as a decimal. Correct.
So the y2 next to it, that's 18.
Yeah, so when you add like 9 tacos plus 9 tacos, you get 18 tacos. So it's just like 18.
I did the 18. So we're supposed to do 18 times 18 square root of 3.
Yeah.
I got 561.
Did you do 1/2 of 18 times 18?
It's not y2, it's 1/2.
No, this is 1/2.
Oh.
My bad. This one's not as terrible. It gives you all the stuff. Find the area of the rhombus. Again, the formula is. I got you, Keith. Ready? 1/2 of diagonal 1 times diagonal 2. AKA 1/2 of 18 times 18. AKA yeah? Not that bad. Alright, now we're gonna roll into Monday's lesson, talking about the area of regular polygons. So there was 2 things that we did. One of them was how big are the angles in a regular polygon. So this shape has 1, 2, 3, 4, 5, 6, 7, 8 sides. So if you do 360 divided by 8, each angle in here is 45 degrees. Now, if we're looking at the central angle, when you draw a line down, it creates a right triangle. This apothegm cuts this angle in half. So if the angle in the middle is 45, that means that each piece up and down is 22.5. And we don't really need to know that, but we need that to find how big angle 2 is. So if you add 90 and 22.5 and you subtract that from 180, it means that this angle has to be 67.5 for there to be 180 degrees inside of that triangle. And that's where you're going to stop for that problem, just solving for those 2 angle measures. And really it's just 1 angle measure on your test. So nothing super crazy there. So the reason we do 360 divided by 8 is because it's like we're calling this a circle. And you're cutting all 8 pieces of that circle in half. Or, sorry, you're cutting all 8 pieces in that circle into equal pieces. And then here's this bad boy. Alright, so like dark red, like nasty problem. It says the area of a regular hexagon has a perimeter. A regular hexagon has a perimeter of 120 meters. Find the area, leave your answer in simplest radical form. So right now all you know is that you have a hexagon. all you know is that the perimeter is 120. And I gave you an apothem. Yes. Which is great, but the formula to find the area of a regular hexagon is 1/2, that is a 1/2, times the apothem times the perimeter. Do you have an apothem?
Yeah.
Do you have a perimeter?
Yeah.
Yeah, so it's 1/2 the apothem times the perimeter. If you do 1/2 times 10 times 20,
I got 600.
huh?
I got 600. I did 1/2 times 10.
That's how you get 600 tacos. Right? So your answer will look like this on the test, but you can convert all your answers to decimals and see which one matches that 1039. So look for that tomorrow. That's the first question on your test, and I'm just going to say, hey, the apothem is this. That way you don't have to math and solve for the apothem. I'm going to give it to you. You just have to listen for it. And then here we go into Tuesday. All right, Tuesday we did similar figures, talking about area and perimeter of similar figures. So it says these two figures are similar. Give the ratio of perimeters. Give the ratio of areas. From the first figure to the second figure. So we're going this direction. So it has to be new over old. Right? Our scale factor has to go from, how do we get from the first shape to the second shape? So is the shape getting bigger or smaller? So that means that our ratio has to be a number less than 1. New over old. So this is our scale factor. And you can simplify this scale factor by reducing the fraction. I think it's like 8 over 9. Yeah? So our scale factor is 8 over 9, which means that our ratio of perimeters is the exact same thing. And our ratio of areas is calculated by doing the scale factor squared. So 8 squared over 9 squared, which is 64 over 81. So 8 over 9 is a number smaller than 1. That's how you get from the first shape to the second shape. The ratio of perimeters is the exact same thing, 8 over 9. And then to find the ratio of areas, you do 8 squared over 9 squared. Alright, so this one's asking you to apply that knowledge. It says the trapezoids are similar. The area of the smaller trapezoid is 709. Find the area of the larger trapezoid to the nearest whole number. Now you get to kind of pick big over small or small over big. Big over small. So we're going to do 39 over 27. This is the scale factor that we're going to use. Does that simplify down to anything?
13 over 9.
That simplifies down to 13 over 9. Alright, we're trying to compare areas. So what do I have to do to this number to find a ratio of areas? Square it.
169 over 81.
So the areas of those two shapes are compared by the ratio 169 over 81. Now it says the area of the smaller trapezoid is 709. So does that go on top or bottom? And that's where we just do cross multiply and solve for x, the butterfly technique, bat and ball, whatever you want to call it. So 169 times 709. Ooh. Equals a big old number like that. Divide both sides by 81. Nearest whole number would be 1,479. Cross multiply and solve. So you change your scale factor to do an association or a proportion for areas, and you cross multiply and solve. The area of one regular octagon is 35 centimeters squared. What is the area of a regular octagon with sides 5 times as long? So we have an octagon. The area of this octagon is 35. We have another octagon that's 5 times bigger. So if we're going to set up a ratio to compare their side lengths, you have to kind of figure out how long is each side of this octagon. What do you want to do? Smart number would be 1. That means if you have a new octagon over here, how long is each side length of that octagon? 5 times bigger, or 5. So if you set up a ratio of side lengths, you can do like small over big equals 1 over 5. This is your scale factor to get from here to here. Now, if we're going to set up a proportion to compare areas, we have to square both pieces. It gives us the area of a small shape, and we're looking for the area of the large shape. So we do 1 over 25 equals 35 over x, so we can cross multiply and solve for x. We're 875 centimeters squared. So because the side lengths are 5 times bigger, the area is 25 times bigger. It says two triangles are similar. The larger triangle has an area of 563 square feet. Find the area of the smaller triangle to the nearest whole number. Okay, kind of setting up the same thing. You can do big over small. To find their scale factor, you can kind of reduce this to a nice number, which would be 8 over 7. So their scale factor is 8 over 7. To set up a proportion that compares areas, you're going to square both sides, or square the top and square the bottom. You get 64 over 49. It says the area of the larger triangle is 563, and you're looking for the area of the smaller triangle. So 563 times 49 is 27,587. $64 times x, and you divide both sides by 64. So to the nearest whole number, the area of the smaller triangle is 431. Nope, I think I skipped number 16. Let's go to 17. It says find the similar ratio for the perimeters of the two regular pentagons if you have an area of 16 over 49. So right now we have an area ratio, which is 16 over 49. We're trying to go backwards and solve for a perimeter ratio. Remember that every area ratio is a squared over b squared. So we have to undo that to find a perimeter ratio that's a over b. So how do you undo a squared and b squared? How do you undo a squared? Square root. So we take the square root of 16 over the square root of 49. So their ratio of perimeters is just 4 over 7 by doing the square root of the top and the square root of the bottom. Ooh. The dimensions of each trapezoid is multiplied by a scale factor of 2. Which statement is true? Let's see. 2 trapezoids. So if we set up a scale factor, it would be 1 over 2. 1 over 2 and 1 over 4. Scale factor, perimeter ratio, and area ratio. Is the perimeter 4 times bigger? The perimeter is 2 times bigger and the area is 3 times bigger? Or the perimeter is multiplied by 2 and the area is multiplied by 4? What do you think? If this is your big shape and this, or I'm sorry, if this is your small shape and this is your big shape. So if you do small shape is 1, you would multiply by 2 to get to the big shape. If your area of your small shape is 1, you'd multiply by 4 to get to the area of your big shape. So it's a 1 to 4. Yes. How would you do this question? What would y'all do? There's 2 different ways to do this. I kind of want to know what you're going to do so I can mimic that for you guys. Are you going to find the area of 3 shapes or find the area of 2 shapes? 3. So if you're going to find the area of 3 shapes, you'll find the area of this shape, and this shape. So if you find the area of this trapezoid, it's 1/2 base 1 plus base 2 times the height. So the area of this shape is 60, which means the area of this shape is 60. And you have to find the area of that kite. The area of the kite is 1/2 of one diagonal 20 times the length of the other diagonal. So if from here to here is 24, and that's 16, what's left over for this piece right here? 8. So this diagonal is 8. So 1/2 of 20 times 8 is 80. That means that the area of this kite is 80. If you add 60, 80, and 60 together, you get the area of all three shapes. The other way to do that would have been to do the area of the rectangle plus the area of the triangle. You could have found the area of this rectangle, 6 times 24. Then you could have found the area of this triangle, 1/2 of 8 times 14. Just a fun question. And the last one says, the area of a parallelogram is 280 centimeters squared. The height is 35. Find the length of the base. So you have a parallelogram. The area of this parallelogram is 280. The height of the parallelogram is 35. And you're solving for the base. So area is equal to base times height. We have an area of 280. We have a height of 35. And we don't know how long the base is. So to solve for x, divide both sides by 35. 8. Centimeters. So the only question that's on the test that's not actually on the review looks like this. It says you have a pentagon, the hypotenuse is 10, one side length is 8. What is the area of that shape? So because it's a regular pentagon, you have to use 1/2 the hypotenuse times the perimeter. 1/2 times 10 times the perimeter of that shape. So if one side length is 8, what is the perimeter of the pentagon? 40, because it has 5 congruent sides. So the area of this shape would be 200. That's the last question on your test. It says it gives you all the information. Just solve for the area of that shape. So that's your review. You can take that home and study it tonight. The video will be up today later. Next week we'll go into surface area